Hi everyone. So today's problem of the day is maximum number of jumps to reach the last index. And what is given in description? We are given a zero index array num of n integers and an integer target. You are initially positioned at index 0. In one step, you can jump from index I to any index j such that I should be less than j and I should be greater than or equals to 0 and j should be less than n. And the second condition is nums of j minus nums of I should be greater than equals to minus target to less than equals to target. Return the maximum number of jumps you can make to reach index n minus 1. If there is no ways to reach index n minus 1, return minus 1. So what will be given in the question? We will be given nums array. And in nums array, suppose we have one nums array, something like 1, 4, 8, 9, 10, something like this, and we will be giving some target integer, and target integer is something like 3. So we will be starting from 0th index, and we need to jump to a particular index if that index satisfy the condition that nums of that particular index, if that particular index is j, then nums of j minus nums of I, absolute difference of this should be less than equals to target. Then only we can jump that particular index. Like that, after jumping to index, we need to reach the last index n minus 1th index. And to reach that n minus 1th index, we need to find what will be the maximum number of jumps. And if we will not be able to reach this n minus 1th index, then we can return minus 1. If we It can be a condition something like 1, 4, then 11, and k is something like 3. Then there is no way to reach this last index because the difference should be less than equals to 3. But if you will try from 0th index to this index, then difference is 3. So we can jump to this index. But from jumping from this index to this index, the difference is 11 minus 4. 11 minus 4, that is 7. So we will not be able to, which is greater than 3, so we will be not able to reach this index. So in that case, if we will be giving some array like this, where it is not possible to reach n minus 1 index, we can directly return minus 1. So this is the question, and we will be understanding more with the help of example. In example, it is given like this is our array and target is 2. So we will be trying to reach till this last index, n minus 1 index, and we will be starting from the 0th index. Now we have 1. 1, if we will try from 1 to 3 minus 1, it is 2 and it is less than equals to target. So we can jump to this index. From 3 to 6, if we will try to 3 to 6, 6 minus 3, it is 3, which is greater than 2, so we will not be able to jump to this index. Now 4 minus 3 is 1, so we can move to this index. Now 4 minus 1 is 3, so we will not be able to move to this index. Now 4 minus 2, 2, so we can move to this index. So how many jump it need us to reach this n minus 1th index? It is 3 because we first is this, second is this, and third is this. So the answer for this is 3. And if you will try to understand with the second example is 1, 3, 6, 4, 1, 2. So we are starting from this index. Now for to go to this index, it will be 3 minus 1, it is 2, which is less than equals to target. So we can move to this. Now 6 minus 3 is 3, which is also less than equals to target. So we can easily reach here. Now 4 minus 6, an absolute difference, so it will be 2. So 2 is basically less than equals to 3, so we can reach here as well. And same 1 and then 2. So how many jump it needed? 1, 2, 3, 4, and 5. For this example, our answer is 5. Now, if you will see in these type of examples, what basically is happening. If you will consider this first example, 1, 3, 6, 4, 1, and 2. So we are moving from one index to next index, the next index to next index. So if we are at one particular index, and there are so many ways to come to this index, then like we can directly jump from this index to this index. We can go from this to this, then this to this. So, but from this index to reach the maximum index, like n minus 1th index, there can be a one there can be so many ways, but there can be only one answer, that is maximum jump will be one only. What will be the maximum jump to reach this index? So we are in a condition where this point we can reach from many ways, but from this particular index to reach here, there will be the maximum jump, it will be constant only. So this is a kind of, because there are so many repetitive cases and we need to store the value of particular index value so that we can utilize it later. So we can use DP here. If you will see the constraint is like nums dot length can start from 2 to 10 to the power 3, and value can range from minus 10 to the power 9 to 10 to the power 9, and target can be maximum to 2 into 10 to the power 9. If it is 10 to the power 3 n, but if you will try to solve it with recursion, it will be the time complexity will be exponential. So if the time complexity is something exponential, then this will then 10 to the exponential की power 10 to the this 10 to the power 3, then it will be much greater than equal to 10 to the power 8. So it will give me TLE. So what I can use, I need to use DP. But to use DP, I need to first try to solve it with the help of recursion. So what I did this is my recursion solution. What I did in my recursion solution, basically I initialized my integer, which is denoting the size of the nums array, and then I am using this recursion function. And what I am doing in this function is like this nums is the array, zeroth like I am at zeroth index currently, and is the total length of the nums array, and target is the target. So nums I, n, and t. If I reach till n minus 1th index, then I can basically return 0, because I reached till that index. I want to reach to that index only, so I can return 0. If and then I can initialize my answer as the minimum integer possible. I denoted minimum integer as something 1 minus 1 E9. You can take it something else also. I just initialized with the minimum integers. Then I I have written this for loop where I am starting from the I plus 1th index till nth index, and I will be trying to find the absolute difference from this ith index to the every possible index from I plus 1 to n minus 1th index. And if that absolute difference is less than equals to the target, and I'm denoting the target as T. If it is less than equals to the target, then I can travel. I can recurse. I can move to the jth index, because I am able to move from I to j. Now I can make my loop from j. Now if my this next is not equals to minus 1 e to power 9, why I have written this. Suppose I am at some array and I am at particular ith index and I reach till this jth index, but it is not possible from jth index to reach till n minus 1th index. If it is not possible to reach till n minus 1 index, so this next will give me some negative maximum value, that, and we are denoting it with minus 1 e to power 9. That will denote that I'm not able to reach till n minus 1th index. But if it is not equals to minus 1 e to power 9, that means there is a way to reach till jth index. So I can do answer equals to maximum of answer comma 1 plus next. 1 why? Because reaching from 1 to j, we are doing one jump, then plus next, and at the end we can return our answer. This is the recursion. And to do the memorization, what we can do is like, this is top down approach. We basically, to convert recursion to top down approach DP problem, what we can do, we can initialize. Now we can see in this recursion function how many variables are changing. So only this ith variable is changing. Rest nums and t and dp is same only. And since only one variable is changing, so we will be declaring dp of 1D array. 1D array vector we can declare. Then what I will pass this vector dp vector in this recursion function, and then I can see if dp of I is not equals to minus 1. That means I have not yet reached till that index, and I initialize it with -1, and still it is -1, then I can start moving to this for loop and I can solve. But if it is not equals to -1, that means I already reached till that particular ith index. Then I can basically return that value instead of like again calculating. I can directly return it. And at the end, I this y equals to answer. I can show my answer in that of y, so that I can use it in data stream. So this is easy. This is easy. Need to TV, but to use this TP if it is not equal to the initially that the value we initialize is not equal to that value, then we can that if it is equal to that user code logic, and at the end we need to use the first step and to assign it a value to that DP so that we can use it in heat district. This is a top-down approach. If I will try to, since top-down approach is using additional space, recursive use space. So what I can do is I can use this tabulation also. We can use this tabulation also. What tabulation? Tabulation is same only what we have done in top-down. We did the same thing in top down. We did this. Now the only thing from converting from top down to tabulation, that is bottom up approach. What we can do is we can initialize. We need to find write the base case. The base case dp of 0 equals to 0. Why dp of 0 equals to 0? Because if there is n minus if the length num's length is 0, then the answer will be 0. Only the maximum way to reach till n minus 1 index will be 0. So dp of 0 equals to 0. Then I am starting from 0 index till n. If it is equals to -1, that means I have not reached to that index. So I can do continue. Otherwise, I can start from I plus 1 index till n minus 1 index. I can find the absolute difference. If it is less than equals to target, I can do dp of j equals to maximum of dp of j comma dp of I plus 1. And at the end, I can return this dp of n minus 1 because I reached till n minus 1 index. So yeah, that's it. And if you will see the time complexity, so time complexity in this case will be big of n and big of n square, because we have used two loops here. And space complexity, we will see space complexity will be big of n only because we have used only one vector. So yeah, thank you.